Pre-calc students, I wanted to give you one example of the change of sign method for solving inequalities, particularly those involving rational expressions, although the same process would apply for any inequalities. All right, so here's the example you see here. This is one from your notes, in my opinion, the most complicated of them. The first objective is we have to move everything to one side of the equation. So we'll have 3x over x minus 1 minus x over x plus 4 minus 3 less than or equal to 0. In order to use our change of sign method, we have to have one fraction. So we only have factors in a numerator and a denominator, not separated by addition or subtraction like we have right now. So common denominator is what we have to do first. So our first term, we would multiply by x plus 4 over x plus 4. The second term would have to be multiplied by x minus 1 over x minus 1. And the last term, the 3 that's sitting there by itself, would have to be multiplied by the product of x plus 4 times x minus 1, which would give us an x squared plus 3x minus 4. And of course, that's over the same thing. And we're still going to be less than or equal to 0. Okay, a little algebra here to simplify things. 3x squared, go ahead and distribute, plus 12x minus x squared, and it's plus x. Then we'll have minus 3x squared minus 9x, and finally plus 12. And remember, that entire numerator is over x minus 1 times x plus 4. Okay, the next step is simplification. Combine your like terms. Negative x squared plus 4x plus 12 is what we'll have in our numerator, divided by x minus 1 and x plus 4 still. And again, we're still less than or equal to 0. Now we need to factor the numerator, but we run into a bit of an interesting situation here in that we have a negative lead coefficient. So what I'm going to do is actually divide both sides of the equation by negative 1, and this should give us a factoring problem that we're more used to. So my numerator has now been multiplied by negative 1. And remember, when you multiply or divide an inequality by a negative number, you've got to switch the sign. All right, now we have something that we can factor. X minus 6 times x plus 2 divided by x minus 1 times x plus 4, and it's still greater than or equal to 0. The setup work is now done. The key is we found our key points. They come from the factors both in the numerator and denominator. They're going to be at 6, negative 2, 1, and negative 4. So we're going to sketch a little number line. And we'll put these points on there. This doesn't have to be spaced evenly. All that matters is that it is, in fact, in order. The next thing I'll do is list all the factors. X minus 6, x plus 2, x minus 1, and x plus 4. They all need to be listed in a format similar to what I've done. You'll notice that I've included the factors both in the numerator and denominator. Okay, so the job we have now, the question that we have to ask ourselves if I'm looking at the factor x minus 6, is it positive or negative if my input, my x value, is less than negative 4? So if you picked a number less than negative 4, like say negative 5, and plugged it in, what would I get? Well, negative 5 minus 6 is negative 11, but most importantly, we know it's negative. And as a matter of fact, with negative 6, whatever input you use, until we get to positive 6, it's going to continue to be negative. And then as soon as we move past 6, that changes to a positive factor. Let's go through that same process with x plus 2. It's going to start as a negative when we're below negative 4. When we're between negative 4 and negative 2, it stays the same. But then as soon as I get between negative 2 and positive 1, for example, the number 0, 0 plus 2, that's positive. And it's going to stay positive as we move to the right. Now we'll continue that process. X minus 1, that's going to be negative and negative and negative. As soon as we get past 1, it changes. And finally, x plus 4. That one starts negative and then immediately changes to be positive value. Now the key to this whole process is to understand that when you multiply or divide positive and negative numbers, what your result will be. So I can see right here, if I'm at a value, an input value of less than negative 4, that I would see 4 negative factors. So I'd have a negative times a negative divided by a negative times a negative. 4 negatives would give us a positive. Whereas in the next group of numbers, in between negative 4 and negative 2, we would have 3 negatives and 1 positive, and 3 negatives and 1 positive gives us a negative. Anytime we have 2 negatives, it's positive. 1 is negative, and of course when we have 4 positives that are multiplied or divided, we'll end up with a positive result. Now the key to this is now that we have to interpret what this data means. Now if we look back here, it says x minus 6 times x plus 2 divided by x minus 1 times x plus 4 is greater than or equal to 0. We know numbers that are greater than or equal to 0 have to be positive. There, and there. That's where our solutions are going to lie. We have one more thing we have to do though, and that is we have to figure out, are we including the key points, the 6, the negative 2, the negative 4, the 1, are they inclusive or not? And when I look at this symbol, it says greater than or equal to 0, which implies that it includes all those points. But if you look back at this factored form of our inequality, we have some domain restrictions. X cannot be 1 and x cannot be negative 4. So we will put open circles on 1 and negative 4, and then we'll fill in the circles on 2 and also at positive 6. Now we're starting to see the answer come together in the number line form. You can go ahead and draw that in. So visually, that's where the solutions would lie. We're going to go ahead and write this out using our interval notation now. So it'll start at negative infinity and stop when we hit negative 4, and again it's not inclusive. At 2, we are inclusive, and that stops at 1. And then our last set begins at 6 and continues on infinitely. I hope that helps you. If you need to watch this video again to see that process, feel free. Also feel free to come in and ask questions, get some help, do what you need to do so you have this figured out. Have a great day.